Dear students, welcome to EPG Pathshala. Today we are going to discuss on fossil fuel classification and its composition. Fossil fuels are the major contributor of energy in this world, and this contribution is from coal, oil and natural gas. This fossil fuel is produced or formed by the deposition of the dead remains of plants and animals underwater for millions of years, and the high pressure and temperature made them to convert into the molecules which are rich in hydrocarbons. And if you look into the geological time scale, we can say that the major coal deposits happened during the Carboniferous era, that is 350 million years back. And these fossil fuels are non-renewable in nature, so it is finite and will deplete one day. It is our conventional source of energy. So in this module, we will be discussing on some characteristics of this fossil fuel, the classification of fossil fuel, mainly the coal, oil and natural gas. Coal in detail, how it is originated and what are its composition and classification. We will see the theories of the origin of fossil fuels, mainly the two theories, the biogenic and abiogenic theory. We will see the classification and composition of oil as well as the gaseous fuels. Fossil fuels are combustible in presence of heat and oxygen. It is a concentrated fuel and it is having the high calorific value, which make it more popular or preferable fuel. It is formed naturally from plant and animal matter over the millions of years, and it consists of mainly the hydrogen and carbon. It's highly stable with hydrogen and carbon bonding. It's a cheap source compared to a non-conventional energy source. Origin of fossil fuel. Sedimentary rock formations are the most common geologic environment for storing oil and gas. There are two theories to explain the origin of fossil fuel. One is biogenic theory and the other is abiogenic theory. Let's see the biogenic theory in detail. In this theory, it's a type of biochemical precipitation called organic sedimentation forms fossil fuels. Carbon-rich organic material called peat can be formed when vegetation dies and decays in aqueous environment such as swamps. If peat is buried by subsequent geological activity, the buried peat is subjected to increase in temperature and pressure, and peat can eventually be transformed into coal by the process of coalification. An analogous process is used in this biogenic theory of the origin of oil and gas. Hydrocarbon mixtures can exist in solid, liquid or gas phase in the reservoir. The phase depends on the composition of the mixture and the temperature and pressure of the reservoir. The elemental mass content of naturally occurring hydrocarbon mixtures ranges mostly from 84 to 87% carbon and 11 to 14% hydrogen, which is comparable to the carbon and hydrogen content of life, and this is an evidence for the origin of petroleum from biological sources. The oil and gas formation begins with the death of microscopic organisms such as algae and bacteria. The remains of the organisms settle into the sediments at the base of an aqueous environment as organic debris. Lake beds and seabeds are examples of favorable sedimentary environment. Subsequent sedimentation buries the organic debris. The rise and fall of sea level as well as other geologic processes continue the process of burying the organic debris. As burial continues, the organic material is subjected to increasing temperature and pressure and is transformed by bacterial action into oil and gas. In many cases, the organic material is contained in sediment that originally had a muddy composition such as silts and clay. The transformation of organic material into oil and gas often occurs in shale, which can be formed by the application of heat and pressure to muddy sediment. Consequently, shale is a common source rock for oil and gas. Petroleum fluids are usually less dense than water and will migrate upwards until they encounter impermeable barriers and are collected in geologic traps. The accumulation of a hydrocarbon mixture in a geologic trap forms an oil and gas reservoir. So, in the biogenic theory, the origin of oil and gas begins with the death of organisms that live on or near the surface of the earth. While in abiogenic theory, the processes deep inside the earth in the earth's mantle form petroleum fluids. As per abiogenic theory, the simple inorganic and organic molecules in the interior of the forming earth were subjected to increasing heat and pressure and eventually formed more complex molecules. Crustal oil and gas reservoirs are formed by the upward migration of petroleum fluid until the fluid is stopped by impermeable barriers and accumulates in geological traps. Let's see the classification of fossil fuel. So, the organic material are heated and compressed over time to form oil, gas and the coal. So, it can be classified as solid fuel, liquid fuel and gaseous fuel. Coal. It is a combustible rock that is composed primarily of carbon-rich organic material. Coal is a heterogeneous sedimentary rock that reflects both the different sedimentological regimes within which peat forms and varied vegetation types from which it is derived. The formation of coal from organic debris is by a process of qualification. We have seen it. When some types of organic materials are heated and compressed over time, they can form water, gas and coal. In some cases, a high molecular weight waxy oil is also formed. This is also saying by this is the same thing which is this is what the biogenic theory says. For example, bog or swamp vegetation may be buried under anaerobic conditions and become peat. Peat formed by the decay of the vegetation under anaerobic condition is a called precursor. It is an unconsolidated deposit of partially carbonized vegetable matter in a water saturated environment. If peat is buried by rock in a depositional environment, it is subjected to increasing temperature and pressure. Volatile products and water migrate away from the formation. The resulting carbon-rich compressed residue is coal. So, the organisms that form coal when subjected to qualification include algae, phytoplankton and zooplankton. The coal can also be formed by the bacterial decay of plants and to a lesser extent by the animals. The organic debris is composed primarily of carbon, hydrogen and oxygen, and so it may also contain minor amounts of other elements such as nitrogen and sulfur. So, based on the substrate from which the coal is formed, the composition varies. The classification of coal. Generally the coals are classified by rank. Rank, it is a measure of degree of qualification or maturation of carbonaceous material. It is classified into lignite, subbituminous coal, bituminous coal, anthracite. And also the highest one which is having more carbon is known as graphite, but it is not coming under the type of the coal. The four types of coal are lignite, subbituminous, bituminous and anthracite. Lignite is the lowest rank of coal, while anthracite is highest rank of coal. Coming to the composition, the organic origin of coal provides an explanation for the elemental composition of coal, which ranges from almost pure carbon to compounds of carbon with other elements, as we have already seen, that is hydrogen, oxygen and sulfur. So, this chemical composition of coal has a strong influence on its combustibility. The chemical composition, especially the carbon content of coal, are as follows. Lignite contain around 60 to 70% carbon on dry ash-free basis. Subbituminous coal has 71 to 77% carbon, bituminous coal 77 to 87% carbon and anthracite more than 87% carbon. And this coal may contain hydrogen content of near around 5%, oxygen around 10%, sulfur and nitrogen around 0.5 to 1%. The gradation of Indian coal is based on its calorific value, and in India the coal is graded into A, B, C, D, E, F, G. There is 7 grades based on the calorific value. A is having the highest calorific value, which is exceeding 6200 kilocalories per kilogram. B is 5600 to 6200. C is 4940 to 5600. D grade is 4200 to 4940. E grade 3360 to 4033. D grade is 4200 to 4940. E grade is 3360 to 4200. F grade has calorific value of 2400 to 3360, and G grade is having the calorific value of 1300 to 2400. And in Indian industry, the most widely accessible grades of coal are D, E and F grades. Oil and gas. These are the terms that refer to the mixture of hydrocarbon molecules in liquid phase and those in the gaseous phase. It is normally a synonym to petroleum. Petroleum, the word derived from Latin words petra, which means rock, and oleum means oil. It is the another term for a hydrocarbon mixture found in this nature. And as per US Energy Information Administration, which defines conventional oil and natural gas production as the crude oil and natural gas that is produced by a well drilled into a geologic formation in which reservoir and fluid characteristics permit oil and natural gas to readily flow to the wellbore. And the unconventional oil refers to hydrocarbon production from low permeability shale and tar sands. Unconventional gas refers to gas production from coal, which is coal gas, low permeability sand, that is tight gas, and low permeability shale, that is shale gas. The primary difference between these conventional and unconventional oil and gas is the ability of the fluid to flow through rock. So, most crude oil is refined for use in the transportation, while gas is used to generate electric power and as a fuel in industrial, commercial and residential sectors of the economy. Nowadays, these CNGs are also common, that is used in the automobiles. Crude oil is a mixture of hydrocarbons that exist in liquid phase in natural underground reservoirs and remain liquid at atmospheric pressure after passing through facilities on the surface that separate gas and liquid. Petroleum liquid typically refers to crude oil and natural gas plant liquids. Natural gas is typically methane with lesser amount of heavier hydrocarbon molecules like ethane and propane. That is the component of natural gas is the methane. If the natural gas contains liquids dissolved in the gas phase at high temperature and pressure, the liquids can condense out the gas phase when the temperature and pressure of the gas is reduced. The change in temperature and pressure typically occurs when gas is produced from a subsurface formation to a facility on the surface. The liquids obtained from the gas are referred to as condensates or natural gas plant liquids. So, this is also comes under the liquid fuel, fossil fuel. The total energy utilization in this world relies about 30 to 35% on petroleum liquid. The common elements found in crude oil and natural gas are the carbon is around 84 to 87%, hydrogen around 11 to 14%, sulfur 0.6 to 8%, nitrogen 0.02 to 1.7%, oxygen 0.08 to 1.8%, metals 0 to 0.14%. So, the actual elemental composition depends on factors such as molecular composition of the source, reservoir temperature and reservoir pressure. Coming to the classification of liquid fuel. The hydrocarbon fluids that are one phase at the temperature and pressure in the reservoir often becomes two-phase fluids when they are produced to the surface where the temperature and pressure are lower. And we have seen natural gas, it is a mixture of hydrocarbon in the gaseous state at surface conditions. But heavy oils do not contain much gas in solution at reservoir condition and have a relatively large molecular weight. While in the light oils typically contain large amount of gas in solution at reservoir conditions and have a relatively small molecular weight. There is a thumb rule for classifying the hydrocarbon fluid types. It is mainly based on the separator GOR, that is separator gas oil ratio. It is a useful indicator of fluid type. It's a ratio of gas produced at the surface to the liquid produced. The unit SCF slash STP, that is STP, that is standard cubic feet or the stock tank barrels, equals the unit SCF by STP, that is the standard cubic feet per stock tank barrels, equals 1 standard cubic foot of gas per stock tank barrel of oil. So the gas volume in SCF is at normally the gas volume in SCF at surface temperature and pressure, and the oil volume in STB is at stock tank temperature and pressure. So based on this separator gas oil ratio, the fluids are divided into dry gas, wet gas, condensate, volatile oil, black oil and heavy oil. You can see in this table the separator GOR values for these various fluid types. In dry gas, there is no surface liquids, so it remains as gas in the reservoir. Wet gas having a value of greater than 1 lakh and it remains as gas. Condensate has a separator GOR value of 3000 to 1 lakh and it behaves as gas with liquid dropout. Volatile oil has a value of 1500 to 3000 and it behaves like a liquid with significant gas in it. Black oil is having SCF by STP 100 to 1500 and it is liquid with some gas. Heavy oil, the separator GOR value is 0 and there is no or negligible gas formation occurs in it. The hydrocarbon liquids are classified based on the properties of the hydrocarbon liquid such as viscosity and the density. The ratio of hydrocarbon liquid density to water density is the specific gravity of the hydrocarbon liquid. And the specific gravity can be calculated as hydrocarbon liquid density is equal to water density divided by the specific gravity. American Petroleum Institute gravity, that is API gravity, is calculated using specific gravity and it is expressed or it is calculated as API is equal to 141.5 divided by specific gravity minus 131.5. Let's see the classification of hydrocarbon liquid based on API gravity and viscosity. This table shows a hydrocarbon liquid classification scheme using this API gravity and viscosity, and based on the API gravity, the liquid hydrocarbons are divided into light oil, medium oil, heavy oil, extra heavy oil and the bitumen. You can see the API values. From light oil, the API gravity is getting reduced. And here the water properties are included in this table just for the comparison. So the water viscosity is 1 centipoise and the water density is 1 gram per cubic centimeter at 60 degree Fahrenheit. A liquid with smaller viscosity than water flows more easily than water. Gas viscosity is much less than water viscosity. Tar, on the other hand, has very high viscosity relative to water. You can see the viscosity values, the extra heavy oil and bitumen are having high viscosity. Based on the density, the classification of crude oil is light oil, which is having less than 0.87 gram per cubic meter, medium oil 0.87 to 0.0, medium oil is 0.87 to 0.92, heavy oil has a density of 0.92 to 1 gram per cubic meter. So these are the different types of crude oil based on the density. The crude oil is less dense than water, while extra heavy oil and bitumen are denser than water. So that's why the crude oil float on water while the extra heavy oil and bitumen sink in water. Normally the crude oil is separated into different fractions by the fractional distillation method in the refineries. So it works on the principle that top portion of the fractionating column having lower boiling points than that at the bottom is getting removed. So you can see in this figure the separation of different fractions of crude oil. So at lower temperatures the gaseous and at higher temperatures the lubricating oil, paraffin wax, etc. is getting separated. Shale oil is the solid bituminous material contained in low permeability shale. Any oil liquid is obtained when the material is heated. An oil material. So, when the material is getting heated, it produces an oily liquid. So, that is the shale oil. Tar sands, it is also known as natural bitumen. It's a combination of clay, sand, water and bitumen. So, the World Energy Council estimated that the shale oil reserve base was approximately 4.8 trillion barrels, and this table shows some of the nations, the topmost nations with largest volume of shale oil, and the forerunner is the United States. Coming to the classification of gaseous fuel oil, the commonly used gaseous fuel are LPG, that is liquefied petroleum gas, natural gas, producer gas, blast furnace gas and coke oven gas. Liquefied petroleum gas. Out of this, the most common are the LPG and the natural gas. Liquefied petroleum gas. It is a predominant mixture of propane and butane with a small percentage of unsaturates, that is propylene and butylene, and some lighter 2-carbon as well as heavier C5 fractions are also present in it. LPG is defined as those hydrocarbons which are gaseous at normal atmospheric pressure but may be condensed to the liquid state at normal temperature by the application of moderate pressures. Although they are normally used as gases, they are stored and transported as liquids under pressure for convenience and ease of handling. Liquid LPG evaporates to produce about 250 times volume of gas. LPG petroleum gas vapor is denser than air. The butane is about twice as heavy as air and propane is about 1.5 times heavy as air. Consequently, the vapor may flow along the ground and into the drains, sinking to the lowest level of surroundings and be ignited at a considerable distance from the source of leakage. In still air, vapor will disperse slowly. Escape of even small quantities of the liquefied gas can give rise to large volumes of vapor, air mixture and thus cause considerable hazard. So, in order to aid the detection of atmospheric leaks, these LPGs are required to be odorized. And also there should be adequate ground level ventilation where LPG is stored, and that's why we usually says these LPG cylinders not to be stored in the basements without any ventilation. Natural gas. It's a source of relatively clean energy that can be obtained from such sources as conventional oil and gas fields. Unconventional gas resources, landfill gas and municipal solid waste gas. Out of this, the natural gas normally, but we are more concerned about the natural gas which is produced from the fossil fuel. So, it contains the major content. The major content of the natural gas is methane, and it accounts around, this methane content is around 95% of the total volume. And other components which are present in small quantities are ethane, propane, butane, pentane, nitrogen, carbon dioxide and traces of other gases. And also very small amount of sulfur compounds are also present. Since the methane is the largest component of natural gas, generally the properties of methane are used when comparing the properties of natural gas to other fuels. And it is having a high calorific value which require no storage facility. It mixes with air readily and does not produce smoke or soot. It has no sulfur content. It is lighter than air and disperses into air easily in case of leak. And this CNG is largely used as an automotive fuel also. The total energy utilization in the world relies on 20 to 25% of this natural gas. Coming to the unconventional gas resources, which includes gas hydrates, tight gas sands and shale gas. Gas hydrates. These are naturally occurring crystalline complexes that are formed when one type of molecule completely encloses another type of molecule in a lattice. In the case of gas hydrates, hydrogen bonded water molecules form a cage-like structure in which molecules of gas are absorbed or bound. Methane hydrates contain a relatively large volume of methane in the hydrate complex. This hydrate complex contains about 85 mole % water and approximately 15 more percent gas molecules. Normally these gas molecules are methane or some other relatively low molecular weight hydrocarbon. So these methane hydrates are found around the world and they exist on land in subarctic sediments and on seabeds where the water is near freezing. It can also, these are also present in Arctic sands, marine sands, fractured muds and shale. Coal gas, tight gas sands and shale gas are characterized by the low permeabilities. The conventional gas reservoir have permeabilities on the order of millidarcies. The tight gas sands have permeabilities on the order of microdarcies. Gas shale is a low permeability source rock found throughout the world. It has enough porosity to hold large amount of gas, but permeability on the order of nanodarcies makes it difficult to economically produce hydrocarbons. Gas production from shale has flow mechanisms that are similar to those required for gas production from coal. Shale gas must diffuse through the shale until it reaches a permeable path that allows it to flow to a well. Permeable pathways are typically natural or induced fractures. Oil and gas reservoirs and reserves. Several key factors must be present to allow the development of hydrocarbon reservoir. Is the source rock is one of the factors is the source rock for the hydrocarbon. For example, the biogenic theory says that oil and gas are formed by the decay of single cell aquatic life. Shale formed the heating and compression of silts and clays. So, the oil and gas can form when the remains of an organism are subjected to increase in pressure and temperature. A flow path must exist between source rock and reservoir rock. Once hydrocarbon fluid has migrated to a suitable reservoir rock, a trapping mechanism must exist. If the hydrocarbon fluid is not stopped from migrating, buoyancy and other forces will cause it to move towards the surface. And the another factor is time. A source rock can provide large volumes of oil or gas to a reservoir, but a trap must exist at the time oil or gas enters the reservoir so that fluid can accumulate. This graph shows the oil recoverable reserves in the world. The major part lies in the Middle East and North America. It's around 49%, followed by the Latin America and Caribbean. And these are the top oil producing countries. The first position is by the Saudi Arabia, then United States of America, Russia, Canada, China, Iraq, Iran, UAE, Kuwait are some other topmost oil producing countries. What are the disadvantages of this fossil fuel? It has many environmental implications such as emission of greenhouse gases, formation of acid rain, global warming, the carbon emissions, pollution is the air, water or soil pollutions, biodiversity loss, it affects the marine life, it imbalances the ecosystem and it has many health impacts. So to conclude, in this module we have seen the fossil fuels are combustible in nature, it is having high calorific value and containing carbon and hydrogen as major part in it. We have seen the origin of fossil fuel based on two theories, biogenic theory which states these fossil fuel are produced from the organic molecules while abiogenic theory states that these are produced from the inorganic molecules during the formation of earth. The different types of fossil fuel are coal which is a solid fuel, liquid fuels mainly the crude oil and the gaseous fuel mainly the natural gas and the LPGs. We have seen the composition of the coal and based on the carbon content it has given different ranks like lignite, subbituminous, bituminous and anthracite. And we have seen different grades of coal used in India also. The liquid fuels are mainly consist of carbon is of around 84 to 87% and 11 to 14% hydrogen. We have seen the natural gas composition mainly the methane content in it and the LPG is mainly consists of the butane and propane. The unconventional gaseous fuel like coal gas, shale gas, tight sand gas etc. also we have seen. And also finally we have seen the disadvantages of fossil fuels like the environmental implications such as the greenhouse gas emissions, global warming, acid rain, its problem with respect to biodiversity, marine life, pollution, etc., as well as the health impacts.